Exponential function rules from tables. Now, whenever I'm writing an exponential function rule, it will be of the form f of x equals a times b to the x, where a is my start value and b is my growth factor. This means that when I'm writing a function rule from a table, I need to be able to find the start value a and the growth factor b from the table. Let's go ahead and look at this first example. In this first example, I have years x and number of bears f of x. To write a function rule representing this situation, I need to find the start value and the growth factor. The start value is going to be how many bears are there at the beginning, at the start. Mathematically, what that means is, what is the value of f of x when x is 0? How many bears are there when the number of years is 0? I find that in this first row of my table. So when x is 0, f of x is 3. In the beginning, I had 3 bears. Now, I got really lucky that this was in the first row, but that won't always be the case. So just be careful. Make sure you're not just looking for the first row, but you're looking for what is the value of f of x when x is 0. Next, I need to find the growth factor. The growth factor is what I am multiplying f of x by to get the next value. So what am I multiplying 3 by to get 15? What am I multiplying 15 by to get 75, and so on? Now, it's great if you can just look at the table and identify that growth factor. What am I multiplying 3 by to get 15? I can just look at it and say, hey, the growth factor is 5. 3 times 5 is 15. 15 times 5 is 75. And then I know, because I made the table, that 75 times 5 is 375. And 375 times 5 is 1,875. What would I do if I couldn't just look at the table and identify that growth factor? In order to figure out what I'm multiplying by, I would use division. So in order to answer the question, what am I multiplying by 3 to get 15, I would do 15 divided by 3. 15 divided by 3 is 5. So in order to answer the question, what times 3 is 15, 15 divided by 3 equals 5. My growth factor is 5. I can find the growth factor using any 2 consecutive rows in the table. So I could have done 75 divided by 15. 75 divided by 15 is also 5. I could have done 375 divided by 75, that's 5. Or 1,875 divided by 375, that is also 5. Now I have my start value 3, my growth factor 5, and I can write my function rule. When I'm writing my function rule, I always start with f of x, or y equals, and then I write my start value a, 3, times my growth factor 5 to the x. It's also totally fine with me if you prefer to write this as f of x equals 3 times 5 to the x. Those are equally a-okay. It shows me I start with 3, and then I repeatedly multiply by 5. In addition to using the table to write the function rule, I can also use the table to answer some questions about the situation. So how many bears will there be after 2 years? The information I'm being given is that x equals 2. And then I'm asked to find what is f of x. So after 2 years, x equals 2. F of x equals 75. There are 75 bears. So use the table to look for what is the number of bears after 2 years. I can also be told the value of f of x. So there are 375 bears. Tells me that the value of f of x is 375. And I go to my table and see what is x. X is 3. That tells me that after 3 years, there are 375 bears. Let's do some more practice. So in this table, I'm looking for the start value. That's the value of f of x when x is 0. The value of f of x when x is 0. For this table, the start value is 12. You can maybe just look at this and see what you're multiplying by to get the next values in the table. But if you can't, take one value of f of x, for example, 36, and divide it by the previous value, 12. So 36 divided by 12 is 3. That tells me my growth factor is 3. And then I should go ahead and check that 108 divided by 36 is 3. as well as 324 divided by 108 is 3. And I will promise you that that is the case. Now I have my start value a of 12 and my growth factor b of 3. I can write my function rule. Not going to forget to write f of x or y equals. And then I write my start value 12 times 3 to the x power. Alternatively, f of x equals 12 dot indicating multiplication times 3 to the x. In my next example, I'm looking for the start value, the value of f of x when x is 0. My start value is 10. Now in this one, I really hope you can just look at it and see what you're multiplying by. 10 times 20 is, or 10 times 2 is 20, 20 times 2 is 40, 40 times 2 is 80. But if you can't, take one value of f of x, like 20, and divide it by the previous value of f of x, 10. So my growth factor is 10. I'm now able to write my function rule. F of x equals my start value of 10 times my growth factor 2 to the x. So I can use parentheses around the base, or I can write 10 dot, meaning times 2 to the x power.